Warm greetings. Welcome for online video session on operating system. Myself Jagadisha, Associate Professor, Department of Computer Science and Engineering, Canara Engineering College, Bantwar. In the last video session, we saw about the introduction of operating system. In the introduction of operating system, we saw the definition of the operating system and the abstract view of the components of a computer system, and we saw the user view, system view, and defined and the storage structure, that is storage device hierarchy, and we saw the multiprocessing, what is meant by multiprocessing, and multitasking, and single processor system, asymmetric, asymmetric multiprocessing system, and we saw the clustering system and operating system structures and memory layout of the multi-programming system, operating system operations, and etc. So we saw the various topics in the first that is introduction chapter of the operating system. Next we'll see the second chapter of the first module, that is system structure. So operating system structure, that is second chapter of the first module. So these are the topics that is covered in the second chapter: operating system services, operating system interfaces, system calls, types of system calls, system programs, operating system design and implementation, operating system structure, virtual machines, operating system debugging, operating system generation, and system board. Whereas here virtual machine we have studied part in the first chapter, we will continue the further studies in this second chapter. So operating system services, it's an operating system is actually provide services functions that are helpful to the user. It provides services functions that are helpful to the user. And 1 minute, yeah, here what are the services operating system provides are: one is user interfaces, second one is a program execution, third one is input output operation, and graphical user interfaces, file system manipulation, and further is the communication, error detection, resource allocation, accounting, protection, and security. We'll see one by one in this slide. User interfaces. User interfaces is almost all operating system have a user interfaces. So almost all the operating system, you can consider your Android, Unix, or Linux, Windows, or earlier there is a DOS, there is a disk operating system, etc. All operating system are all user interfaces, like without keyboard or without mouse or screen, there is no operating system such that. So each and every operating system are all user interfaces. So interface, that is the user interfaces is the point of human computer interaction. It's a human there is interaction between the devices. This can include the screen, keyboard, a mouse, and the appearance of the desktop, and various between the command line interfaces is there, and graphics user interfaces is there, and it is used graphical user interfaces is used in which Windows system which points in devices to direct input output. That is choosing a that is menus in Windows. There is MS Office. You have menus like files, insert, etc. All are means you all graphical user interface. With the help of the mouse, we can interact easily to enter the text from the keyboard. Some of the examples in the graphical user interfaces. Program execution. The system must be able to load a program into memory and to run that program and to end the execution either normally or abnormally. Normally or abnormally, this operating system, it provides services. Even you can see that whenever you are closing the operating system, without closing any of the application, that is it asks please close the system, that is close the windows which are all opened, otherwise the files whatever you have executed, it won't be saved. It shows like that. So these are the examples of the program execution. Third one is a input output operation. A running program may require input output which may involve a file or an input output devices. For specific devices like functions, that is for recording purpose CD, DVD drives, or a blanking a CRT monitor, etc. For efficiency and protection, user usually cannot control input output devices directly. Therefore, operating system must provide a means to do input output operation. File system manipulation. The file system manipulation is a particularly interested. That is obviously programs need to read and write a files and directories, create and delete them and search them, list the file information, permission management, etc. Whenever you open a file for particular services, like for to read a file or to write a file in a directory or to create a new file or to search a particular item in a file or to give a permission who can access, read, write, or both permission, etc. Such type of file informations are to give a permission or to access this type of files, the operating system gives a service. This type of services will be given by the operating system. So this is what the file management, file system manipulation. Communication, that is also one more important that is segment in the services provided by the operating system. There are many circumstances that is which one processor needs to exchange information with the another processors. Such communication may occur between the process that are executing on the same computer or same system or between process that are executing on different computer system. That is shared memory as well as message passing are all these are the services provided by the operating system. Even during the error detection or error detection needs to be it is possible in the operating system services. Whatever the errors while installing the any of the application or hardware may not support, at that time error detection, error may pop-up window will provide that is the application or any of the like any other new application or existing application that hardware won't be support, at that time the pop-up window will arises. That is because of the services provided by the operating system. As well as another services is resource allocation. Whenever there will be a number of processes or performing a operation, so at that time one process may ask memory and other process may ask the permission for the other file, etc. Such type of resources allocation has to be done by the operating system, and that services is provided by the operating system. And accounting, and accounting in the sense who are all accessing the services of the operating system, and who are all the process, which are the process is holding the resources of the operating system, etc. Such type of accounting information is being handled by the operating system. That is another services provided by the operating system. And the third one is another one, actually say protection and security. Obviously the most of the operating system now, operating system which is existing like Windows 7, 8, 10, etc., all the operating system is giving a security of the that is virus or theft, some that is malicious viruses which is been that is existing, or which is comes which attacks the system to give a protection for that there is system. The nowadays most of the operating systems will be built in security, there is protection will be given by the there is custom, there is client, so not a client, the producer, that is producer means production of the operating system, as well as nowadays security. So there will be a one-to-one end security. So if the system is handled by only one person, he can give a security for the particular file or maybe the system. No other user can come and access the system individually, because he may crashes the file, or he may crashes the operating system, etc. Such type of chances are there more. So to give a security for that, or there is protection, they will be given a like password, or something else like even face recognition or biometric, like finger biometric or iris biometric, etc. At that time, you can see even in the Shivaji film, that is Tamil Shivaji film, where Rajinikanth, he gives his voice, then only the operating system or system gets open. That is such type of security, where because no other user can come and access the documents of the other users. So that is always, that is better. So this type of so there is services can provided gives by the operating system. Yeah. Next, we'll see the view of the operating system services. That is, you can see here the operating system is above the hardware, and above the hardware there are the services, the various services what we saw in the previous slide. You can see the program execution, input output operation, file system, communication, resource allocation, accounting, error detection, protection and security. All these types of services has to be it has to be performed. That is the services are provided by the operating system itself. Above these services there is a system call. Above the system calls is a user. The user can have give that is provided services to access the services that is provided by operating system with the help of the graphical user interfaces, batch, command line and user interfaces. So then this is the overview of the operating system services. So first it is hardware, above that it's operating system, above that the services, list of services provided by the operating system, and system calls. System calls to access the services of the operating system. There is a particularly there is a system call, like we'll see what are the system calls the operating system provides to access the services of the listed below. And above that system calls there is a user, graphical user interfaces, bash files, command line, and above that the user. So user can access the services of the operating system with the help of the interfaces and with the help of the system calls. This is a view of operating system services. So in the examination they can ask what are the, or list out and give explanation of the operating system services. So in that cases you have to list out first all the services: program execution, input output operation, file systems, communication, resource allocation, accounting, error detection, protection and security. First you list out all the contents and give a explanation one by one. So even they can ask, right, there is a diagram of an operating system services and list out the services of the operating system. So this they can ask like this also. Next, operating system services. There is of course this part I have explained in the previous slide itself. We'll see go through once again. There is another set of the services provided by the operating system is communication and error detection, and one more is resource allocation, accounting, and protection and security. So communication is a processes may exchange the information on the same computer or maybe between other computers through network. Communication may be via shared memory or through message passing. So communication, obviously you have seen go through the in the most of the computer labs. There is a communication between the two computer is able to there is because of the operating system, there is services provided by the both the system through the communication. There is a separate there is services or that is a program is there to provide a there is services for that is by exchanging the messages from one computer to another computer between the or in the network, that is provided by services provided by the operating system. Error detection: operating systems needs to be constantly aware of possible errors. What are the may occur in CPU, or maybe occur in the hardware, or it may be occur in the input output devices, or in maybe in the program. So that is constantly aware the possible errors. The operating systems must be able to constantly aware of possible errors. For each type of error, operating system should take the appropriate action to ensure the correct and consistent computing. So whenever the error occurs, the operating system by itself has to take some action to resolve the error and continue the process of computing. Constantly consistently compute the program or the process. Debugging facilities can greatly enhance the users and programmers' abilities to efficiently use the system. So another set of services provided is resource allocation. When multiple users or multiple jobs running concurrently, resources must be allocated to each of them. The previous slide, and that is first slide, I will explain the resource allocation. There will be multiple processes are running concurrently or parallelly. So one process may has the resources of the other process holding. So for that the process has to wait. So to allocate the resources to the processes, the services provided by the operating system. So many types of resources such there is some are there is memory, file storage, CPU cycles may have a special allocation code. Others such as input output devices may have a general requested and to release code. So once it is been make use of the resources, then it is there is once it make use of the resources, then it after making of use of resources, the process has to release the resources to allocate to the other process. So accounting to keep track of which users use how much and what kind of computer resources, obviously. So each of the resources what are the processes holding has to be keep on accounting. Then only the operating system can allocate the resources to the other process by seeing the accounting information. So last but least, there is protection and security. The owner of the information stored in multi-users or a network computer system may want to control use of that information concurrently. Process should not interfere with each other. So there is protection and security. Protection involves ensuring that all the access to the system resources is controlled. All the there is ensuring that all process to system resources is controlled. Security of the system outsider requires user authentication extend to defining external input output devices from invalid access attempts. If a system is to protect and secure, precaution must be instituted throughout it. A chain is used only as strong as its weakest link. So these are the list of the resources provided by the operating system. Next we'll see user operating system interfaces. So user operating system interfaces, in that first one is a command interpreter, that is command interpreter. Then next is a graphical user interfaces. In this topic, user operating system interfaces, we have two types. One is command interpreter, as well as second one is a graphical user interfaces. So we'll see one by one. There is sometimes see they can call as a CLI also, command line interface, or command interpreter also. So direct command entry, here you usually have seen in your CMD, if you say, type CMD, command line will execute the even you have seen in the MUP as well as even EC also, or whenever earlier, nowadays graphical user interface is there. Before graphical user interfaces, usually we used to write a program in command line itself, and we have to execute the program in command line itself, and we are even output is also in the command line itself. Nowadays there is a graphical user interfaces, sometimes implemented in kernel, sometimes by system program, sometimes multiple flavors implemented, that is shell. Primarily fetches a command from the user and execute it. Sometimes command built-in, that is CLR, that is a built-in function. Date is a built-in function. Calendar is a built-in function. You can type, if you say type a calendar, you can see in the command line the calendar. If you type the date, that you can see the date in the command line. These are all some of the built-in commands are there. And even if you see in the shell, that is a Unix or Linux, there are some most lot of built-in command. If you press ls, it lists out the files, and if you type the CLR, it clears the screen. These are the list of the command line. That is we see in the command interpreter. And some operating system, that is Windows XP or Unix, are all uses a command line interpreter. And special program that is running when a job is initiated. Okay, and the main function of the command line interpreter is to get and execute the user specified command. That is user specified command, like even user can also create a command, and once the program is closed, that command won't exist, that is been cannot be used once again when you switch on the system. And many of the command lines are given at the level manipulated files, that is to create a file, to delete a list, print, copy, execute, and so on, or all the command lines that is built-in command line. Yeah, user friendly desktop metaphor interfaces. And if you see the RM, to rename the command, that is rename the file of the existing file or other file we can use. And so there is yeah. Yeah, second user see, there is operating system interface is a graphical user interfaces. In the graphical user interfaces is a user friendly, it is user friendly desktop interfaces. Usually mouse, keyboard, monitor are all user friendly. With the help of the mouse you can start executing the, that is you can open the file, or you can open the menus, or you can if you see the MS Office with the help of the graphical user interface only, all those things are able to open by the help of the mouse. Otherwise you have to use a keyboard. And icon represents the file program actions. Various mouse buttons over an object in the interface causes a various actions. And many system now includes a CLI and GUI interfaces, like Microsoft Windows is GUI with CLI command shell, Apple Mac OS X, that is interfaces, Unix kernel. And with the help of the graphical user interfaces makes the human effort very less. And see, think about, if it is graphical user interface is not there, and how to open a directory, it's very difficult in the command line interpreter. It's not difficult for nowadays the at this type of at this time it's very difficult, because nowadays all work are all executing very fast. So now if you want to open a folder or create folder, you have to give a mk, that is make a directory, and you have to create a folder. Then after that you have to store a file. To create a file, create that is if you want to text file, .txt. If you want to open a doc file, .doc command. You have to keep on giving a extension also. Nowadays it is not that much difficult. You can directly with the help of the mouse, you can double click, the file get opens, and if you want to save, just go through the file and save it. This is because of graphical user interfaces. Otherwise you have to separately go for the command line and do or etc. all type of changes. So this makes graphical user interface makes easier compared to the command line interpreter. So in the examination they can ask list out the operating system interfaces. One is command line interpreter and another one is the graphical user interfaces. So these are the two there is interfaces used by the operating system. So next it is a system calls. So you can see the previous diagram here. Yeah, you can see here these are the services provided. Above that there is a system calls. So now we came across the system calls. So what actually system calls? It's a program that is written in high level languages, that is C or C++, and it programming interface to the services provided by the operating system. It's a interfaces to access the services that is provided by the operating system. System call is a services to access the services that is provided by the operating system, and the program written of the that is written by C or C++, that is high level languages, mostly accessed by programs via high level application program interfaces. Nowadays the system calls that is mostly accessed by program via is high level application program interface rather than the direct system call users. Three most common application program interfaces are Win32 API for Windows and POSIX API for POSIX based systems, that is including virtually all version of Unix, Linux, Mac OS, etc. That is Mac OS X, and Java API for Java Virtual Machine. Nowadays, most of our applications, there is program interfaces are Java API. So usually Java API are the most running interfaces in the organization, that is in the companies. Why use API rather than the system call? Why do you, when there is a system calls, why do you require a API? So API, it makes the user to understand better, and it is easier than the writing a system calls with the help of the C or C++, where it is very difficult. So now note that system calls names used throughout the text or generic system calls. Yeah, you can see the system call sequences to copy the content of one file to another. So for example, if you want to copy the file content, that is whatever the, for example, you opened a two file a that is two word file A, as well as another one is a B word file. So to copy the content of word A to word B, so what are the procedure in the sequences with the help of the system calls? You can see here, one is examples system call sequences, that is acquire the input file name. Input file name is a source file, that is A, and write a prompt to the screen. Accept the input. Acquire the output file name. What is output? Destination file. Write prompt to screen. Accept the input. Open the input file. If file does not exist, if the file, for example, if you want to move the content A to the destination B, then if A does not exist, then what it has to do? Abort, that is come out from the screen. Otherwise create a output file. If the file exists, abort. So loop, read from input file. If it is the content is available, that is the source and destination, then proceed this. Read from file input file, write it to the output file, whatever it is there, put it into this until read fails, until the last string, that is null, exists. Keep on moving the content from source to the destination file. Then close the output file. Write completion message to the screen, that is the pop-up window. The file completion, that is writing a source file to the destination is over, that has to be pop-up. Then terminate normally. See the procedure, how difficult as is there, and is it possible to write each and every there is a application or every procedure, there is every use of the system. It is very difficult to keep on writing the system call for each and every operation. So for that sake, we have a application program interfaces rather than the system calls. So system call implementation, typically a number associated with each system calls. System call interface maintains a table indexed according to this number. System call interface invokes the indent system calls in operating system kernel and return the status of the system call and return the values. The callers need know nothing about how the system call is implemented, just needs to obey the application program interfaces and understand what operating system will do as a result call. Most details of operating system interface hidden from programmer by API, managed by runtime support library. So there will be a library, runtime library support, that will be managed by the operating system interfaces. So API system call. So previously what we saw the example of a system calls. Now we'll see the API system call operating system relationship. So this is a system call interfaces. That is one is user mode and kernel mode. In the kernel mode, there will be list of files. There is a list of commands will be there, and see user application will be using a application. There is something like MS Office, and open. If you say keep it set means if you press open, then that command will call the system call interfaces. Then that system call interfaces moves to the from user mode to the kernel mode, and there is open means here there will be a list of commands. So open implementation of open, that is system call. There will be list of system call. If you press open, then that within a fraction of second it comes to the system call. From system call it goes to the kernel mode. In the kernel mode, that is operating system receives the, that is what are the services has to be provided by operating system, receives the service, that is command from the user application, that is from the user mode, and it performs the operation and immediately sends the signal to the system call interfaces. Then it returns to the user application. You can see, if you can see the list of menus. If you press file open, then immediately it get open depending upon the RAM speed. If the RAM speed is very less, like 2 GB, it takes at least minimum at least minimum 1 minute. If your RAM speed is up to something around 4 GB or 6 GB RAM or 8 GB RAM, immediately it opens, because the command line, whatever the it sends up, there is command line from user application to the kernel mode, it is within a fraction of second it can do the operation. So this is one of the examples that is being shown by the textbook, that is application program interfaces of the system call. So instead of, see, if you want to open a say there is application file of a file without user interfaces application interfaces, then you have to go for the command line. In the command line you have to give the there is command open, then you have to write a system call to the system call interfaces. You have to write a system call to open a file. So with the help of the there is a API, it reduces the system. There is a human effort of writing a system call. So it's just a graphical user interfaces. With the help of the graphical user interfaces as well as API, it's very easy to open a file. So next we'll see the system call interface, the system call parameter passing in the next classes. So by this we'll end the second video session of on operating system. If you have doubt, you can put it on a comments line, or you can ask in the online video session class, or you can ask in the class also. Thank you all.